Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast.
Welcome back to Application Security Weekly. We just talked with Larry Maccherone about building a mature AppSec program that serves as a constructive coach for your DevOps teams. I'm your host, Mike Shima, and I'm here with John Kinsella, and it's just about time for the news. Don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe on any of our podcast feeds, which I possibly already read this announcement once, but just subscribe again. I do know that I haven't read this other announcement about CRA's Business Intelligence Unit has launched its next survey on Zero Trust. What are your barriers to Zero Trust implementation? Take our survey and enter to win a $500 Tango card by visiting securityweekly.com/zerotrust. Report results will be released at our upcoming Zero Trust eSummit sometime in March. And Mr. Kinsella, this brings us to the news. It's been a busy week. We've even got some crypto articles that I saved just for you to welcome you back and see if your brain is working after you've been out for a bit. But let's go ahead and exercise that brain with a short vulnerability you found about a container escape.
Oh, we're going straight to the good stuff. Okay, cool.
Straight to the good stuff.
Excuse me. Yeah. So, we're I don't know what, probably 2 or 3 years ago, I said that, well, obviously we always say, containers are not security constructs, Linux containers. They're containers, but there's no security boundary there. People often look at me sort of funny. And I think I've sort of said, like, I'm expecting every 12 to 18 months to see another container breakout. And so here we are. Not quite sure when the last one is, but they are hitting about every 12 to 18 months. And really at the end of the day, what's going on here is, excuse the rough voice. Really what's going on is, while the Linux kernel has been around for 20, 25 years now, this container-based stuff, the Linux namespaces, is relatively new that's in there. So that's, as people figure out different ways to sort of bump the thing tonight, we get issues like this. So this was interesting from a slightly different manner. So the title on this is Linux kernel. This is from Bleeping Computer, but Linux kernel bug can let hackers escape Kubernetes containers. Why the specification there? So what this is, what's actually going on is they have found a buffer overflow in the file system context, which is a part of the Linux kernel. And really what they're able to get at that is arbitrary code execution. Once you've got arbitrary code execution, you're sort of in, that's what we consider a pretty good place for a lot of us. But the question is, which stars have to align to allow you to get that little thing to be overflowed? And at the end of the day, that needs a specific type of capability. Capabilities are granted out or they're granted to processes within the Linux kernel. It's another kernel construct. So what we're getting here is a little bit of defense in depth, right? So the container by itself might not be able to do things, but then, you slap some capabilities or you remove some capabilities from that container so it just has what it needs to actually get its job done. And that's something that Docker has done for 4 years now, I think it was, when Jess brought it in. So what in the Docker, what you have by default, and you can look at this in source code on GitHub. If I get bored, I'll post a link into Discord. But what they've done is they've gone through the list of capabilities and said, these ones you probably don't need by default in a container. So when you run a container under Docker specifically, and I'm not sure about Containerd, I know Docker. So by default in there, it doesn't give you every single thing out there, right? You don't have what's called capsysadmin, which is all privileges on the box. It removes some of the kernel module ones. In this particular case, one of the ones which it removes is the ability to do what's called unshare. which is the specific system call which is needed to be able to do this buffer overflow. So it turns out if you're running a Docker container, or if you happen to have a Docker swarm cluster, does anyone still do that? If you're doing that, you're probably okay in this particular case. If you're running Kubernetes, you are not so lucky. So what's going on in the Kubernetes world? There has been a ticket open an issue for, again, not quite as long as the Docker stuff got in there, but it's at least 2 years. What capabilities should we have turned off by default? The problem is, since this has been out and running in the wild for like the last 2-3 years, there's people already using using some of these capabilities. So if you suddenly start removing them, there's going to be a lot of teeth gnashing. I actually thought this had gone through at least into alpha, but it looks like it's not yet. So we'll have to go back and see what the Kubernetes guys are doing there in that area. But so that's it's interesting in certain cases, and this is one of those things. I was talking with Paul when you guys were getting ready for the lab webinar. Some of these things look so simple, and like it looks so easy to put those vulnerabilities together, to put them into a lab and actually get that stuff to work. And he gave me one of the containers to test, and I couldn't get to run on my Mac because I'm on an M1 CPU, right? And like I think the version of MySQL was different, but you really, for a lot of these type of things, they look easy and they look scary, bad. This is going to take over the world. But when you actually go to try and execute the exploit, it becomes a little bit not quite as simple as it looks like in the first place, which is a good thing, I guess.
Which is a good thing, and that's a great setup for the other big beast we'll talk about, PwnKit, because, and I'm going to just reiterate a couple of themes you brought out, because these were themes that I saw in this the PwnKit vulnerability write-up. One was the age of the vulnerability, difficulty perhaps of exploitation, or in this case, ease of exploitation. But the idea, more importantly, I think, of defense in depth, and is this environment vulnerable, or is this other environment not vulnerable, and why? So with that kind of preamble, let's dive into PwnKit, which is some research out of Qualys, and they found basically a vulnerability that's been sitting around not quite unnoticed since May 2009, in which you can have your argc can be equal to 0, which basically means your argv, your array, your C array of arguments being passed on from the command line, essentially. The very first one, number 0, is typically the name of the program being executed. Now, in December 2013, a researcher noted this behavior, but they didn't have a good exploit scenario. They just said, typically bad things can happen here, and oh, by the way, look, there are some other, I think it was GDB and some other applications actually have some explicit safeguards against this scenario where your argc could be equal to 0, or basically have a null argv 0. Now roll forward another 9 years or so, in January 2022, we get this disclosure about how to exploit this particular situation. And what was interesting is that I was diving into, as I like to do, either look at the fix for the vulnerability to see what does that teach us from a secure coding perspective, or just read about the manual pages for these, in this case, the exec and exec.ve. And the things that stood out for me is that, one, this first argument, I'm quoting here, by convention, should point to the file name associated with being the file executed. That's basically saying what argv0 should be. It shouldn't be null, but that's by convention. It's not necessarily by standard. And if you look at the manual page for exec.ve, and I have these in the show notes, it makes a point about Linux's behavior is a little bit different, and you should be careful about Linux's behavior. And then if you look at the end of the Qualys article, they do note that OpenBSD isn't exploitable because the way that they're handling this PwnKit code is that they're explicitly handling this case where argc is 0. So that's perhaps, hopefully not too confusingly meandering pathway to say there's a vulnerability here in some, this PwnKit, a application that essentially is equivalent to sudo. I'm kind of hand waving a little bit there, but it can be installed on Linux, Unix-like systems. OpenBSD in some cases is vulnerable, some cases it's not. And so it's a very interesting dynamic between how much do you do the secure code within the application itself, call it the dependency, and how much do you do secure and defensive coding within the operating system and the environment executing these, call them dependencies or just call them untrusted, or just applications that you want to make sure remain trusted. So that was kind of a different sort of path. I wanted to start off on this, but I'm not sure if what threads do we need to pick back up here, John?
No, I think you did a pretty good job covering it there. So, yeah, not a lot to add. I've been describing it a little more basically to people and just saying, look, it's an SUID program that someone found a vulnerability in, which means you can end up with a root shell. But I think that the details which you're providing there are wonderfully educational to our audience. That's a good thing. Yeah, no, it's what else can we add on here? We were talking about containers. Folks have figured out this will run in container, and you can get an exploit in there, but that gives you root in the container. But the point is, and this is why I started mentioning it's an SUID binary. Wherever that binary is, you're able to get root there. I think I'm going to come back to this one in a few stories if we mention it. I might come back and talk about rootless systems and where that sort of gets us or doesn't get us, but good write up, good description of a good write up by the Qualls guys, and yeah, it is what it is. Unfortunately, not too much to add. Sorry.
It is what it is. That's what I guess that's the second motto right behind it depends within application security. That does lead us to some fun. So we're diving back into some crypto, as in cryptocurrency and not cryptography articles. And the reason I was pulling these out is they had some good meaty technical details behind them. And I think with those technical details are what allows us to educate, to learn for a bit. So, and the other thing is that they're very much in the camp of logic problems or programming mistakes that have nothing to do with argc equals 0 or other C-based kind of memory safety issues. So the first one I'm pulling out here, and there's a technical write-up that I linked to as well, is about the Qubit platform hacked for $80 million worth of cryptocurrency. So the other cool thing is about crypto-based scenarios is that the bug bounty is built right in. Find one flaw in a smart contract, and $80 million later, you've proven that flaw exists. What's interesting about this is that, as I'm sorry, forgot to pull up my notes, is that the write-up nicely walks through 4 different steps to pull off this attack. And the attack basically says, I've deposited some coins, some Ethereum, and I want to withdraw some. But through some unfortunate, incomplete validation checks and some unfortunate verifications on this deposit function, when you have a deposit of 0, meaning nothing, the application fails insecure. So in other words, you're building up a state machine that says X, Y, and Z steps are supposed to happen. And if they're in place, then sure, withdraw some money. But if you have some insecure code, if your state machine isn't quite so well tested and well thought through, you might get some nasty surprises about how these different assumptions work together. And in this case, $80 million later, you can demonstrate by the attacker that the way that the assumption about this deposit function when it has 0 as coming in doesn't actually revert correctly because of the way the state machine was set up. So that was why I was trying not to get too much into the weeds, but set up the idea that state machines are pretty common to all the applications we're building. And when they are security sensitive, or such as call it authentication or authorization types of checks, or in this case, handling money, bad things happen when those security boundaries start to get passed.
I guess I have 2 comments. One for our listeners, a reminder that Mike brought this article and not me. I will be bringing in some crypto stuff over the year, but I didn't see these 2. And the second, I believe the technical phrase is, this is really trash code. So this is why it got on our radar. And why, partially why we're talking about this is not, haha, we found some simple vulnerabilities we can go make fun of. But this, as we were saying 2 weeks ago, this code has been, or excuse me, the relative popularity, let's try it one more time. Crypto coins have been relatively popular, and they're surrounded distributed finance for the last, at least, 3 to 5 years. This code is being worked on by some really sharp folks out there, that love to sit around in academics and talk about this stuff in all sorts of details, which I really don't care about. But nonetheless, even though you've got these great people coming up with these great ideas, the logic is trash. That's really the only way we can talk about it, as far as I'm concerned. Any type of QA, and maybe is there QA done in? I don't know. There's people's research homework for the week is does anybody in distributed finance do quality assurance on their code? I'm sort of wondering. But in seriousness, right? It's when we think about security, one of the core sort of basic concepts is, you'll hear me say, of just poking at things and seeing what happens, right? It's funny. I'm thinking of one of the basic QA things you do, on an e-commerce site, is how many zeros can you put in, or how big of a number can you, and then if you either buy something with, worth $10 million, how does that get processed through the cart? Does that order go somewhere into the warehouse? Counter of that, if I actually try to return something, can I return something with a higher value than what I originally bought? So these are all really sort of common pieces, right? So for someone not to have done the checks on these, which is why I'm using strong language in my response to it. But I think the next one's, I think these are both sort of interesting. I know we've got one more to go through in here. And actually, you didn't. There's another one which I don't think we have in here. There was so I'll go sideways for a tiny second. OpenSea, the purveyors of fine NFTs, those guys had another vulnerability, which I'm not sure if it's the same one we covered 2 weeks ago, or if it's another vulnerability still. But OpenSea, oh man, I've heard the transaction number. The amount of money those guys are going through every day in transactions, it's in the billions. It's insane. But they're able to make enough profit off what they're doing that with that last vulnerability, excuse me, they're able to actually just out of their profits go and pay the people who lost money. And that's sort of how they're keeping the audience, relatively happy when there's significant vulnerabilities in their code base. We'll see how long that lasts and if the other guys can do that. This article had a few people talking about, dude, I've lost it was in the hundreds of ETH. So that's a lot of cash if you ever convert it back to the real stuff. But anyways, that's how about we keep going. You want to talk about the second one, the Motherboard article about Multichain?
Yes,
I think
exactly.
You might have gone a little bit deeper into this one than me. So if you want to dig into it, let's see where it goes.
Yes, and I'll begin the digging in by echoing what you were saying. We've gone from we take your security seriously to unfortunately seeing pretty please can we have our tokens back as the basically the approach to bug bounty from these organizations, which is a bit funny, but not funny haha so much as maybe funny cry, because again, here is another. I'll go ahead and also use the term maybe trash code or not so great code, in the sense that there is a phantom function that was apparently pretty common in older versions of Solidity contracts, the way that they would be expected to have these functions and to be implemented for reversion. In other words, an error happens. What should we do? How should we handle that error? Think of it that way. In this case, there is a fallback function of nothing. In other words, the shim exists, but there's nothing to revert. There's nothing to do if it runs into an error state, or it needs to have that state machine, as I was describing, probably shouldn't continue and execute a transaction. But if there's nothing to fall back to, and the fallback says kind of a shrug, nothing to see here, carry on, then you start to lose millions and millions of dollars based on funny money of the coins. So it really just points back to, again, here is a case where there should be, I think, better security analysis, just from the perspective of what does your call tree look like? What does your state machine look like? Do you have, as John was describing, just some good QA? Do you exercise the state machine? And I'm harping on that because state machines are one of those things too that can be that lend themselves to fuzzing. In other words, here are a bunch of John mentioned, a whole bunch of zeros. What about a value that you've purchased? You purchased your widget for X amount, and you're trying to return it for X minus some number amount, so you can make a profit. Or you have a coupon code. You're trying to reapply a coupon code rather than once, 100 times. These are really common scenarios, and 10, 20, 30 years ago in e-commerce sites. So these are some, I think, I want to say, pretty basic approaches in terms of threat modeling scenarios to be building up and considering. And I think that's the most I can squeeze out of these articles, rather than just harping on the fact that logic functions are just as bad and impactful money-wise as we see, regardless of how memory safe your language is.
And I think two call out there. One being, at least on this article and the Vice article, for clarification, if anyone's reading this, it's not really clear to me. That's why I had to go look it up. So the price of Ethereum today, the 31st of January, what happened to my month? We're trading at around $2,600 US. That's per ETH. And from this article, I got the sense at one point that they were talking about 13 ETH being around that. So no, the dude who lost 13 ETH, that's 13 times $2,500. That'll make you cry a little bit. The second part, excuse me, is I personally don't code state machines very often, and I think it's partially probably due to the style of code I'm writing and where I'm writing that code. But I think if I was going to use a state machine, one of the areas you want to use them is somewhere where you really want to make sure that you are in one of some number of very lockstep states, right? You're going to go from A to B to C. Oh, you have to go back to B. But you're going to be you're not going to be A.5, right? You're going to be in one of those very locked states. Finance is a really common use for those. So again, it's surprising they're not being a little more rigid in their logic there. But here we go.
Here we go, indeed. And maybe, and I know we had Dan Guido on at the very end of 2021 in Trail of Bits. His company does a lot of these kind of smart contract analysis. I think I've read about NCC Group. We've featured some of their articles on non-crypto area, but I know they do some analysis. So throughout the year, perhaps we'll also pull out some of those approaches of how do you do this type of security analysis on these chains to try and also get that educational aspect. But switching now, I think, from the crypto space and the funny money therein into real money coming out of a bug bounty program for around 100K is a nice article about, it's titled Webcam Hacking Again, but it's more about a journey into some edge cases within Safari, how it handles custom URL schemes, things like, rather than just HTTP : a scheme like iCloud-sharing, and getting into some nuances of how Safari handles web archives and the differences, I should say, between, we know here is a file that's downloaded, we're going to allow list it once it's been done because a user has interacted with it. But what was interesting and what emerges from this really nicely written up article is that a web archive might be allow listed because a user has interacted with it. They basically clicked, yeah, go ahead, open this. But behind the scenes, that web archive could then be modified to have completely different content, which means then there should probably be a renewed allow for that, meaning, hey, this content changed, user, are you still sure you want to trust this? But what the problem was that didn't happen. And lo and behold, get a really neat, basically pop calc and get $100,000 out of it. But I think here is the emphasis for me is less on what the vulnerability was able to accomplish and more about a really nice write-up that walks through a step of, there's universal XSS exists. Here's a couple links to the history of that. Here's a couple links to the history of universal XSS within Safari. And so the researcher just shows how to learn from past experience, learn as well as acknowledge other people's work, and then really dive in and poke at something until they're able to find that edge case where that security assumption falls down and they're able to get an effective exploit out of it. So kudos to that. Nice write-up.
Yeah. It was a bit of a shocker to me as well. Same part of hit to you that like, wait, okay. And I believe the phrase he uses on here is you basically have a polymorphic download, which might be pushing it a tiny bit, but that's sort of the point that you're able to re-download something and they're obviously not checking a SHA or whatever sort of checksum you'd want on there, which is not good. Nice payday for him. I'm trying to think if I have anything more to add to this. As you mentioned, that the Project Zero write-up on the MuXSS is quite nice. I think that's probably the bigger takeaway for me here is from an educational point for people. If, we talk about the OWASP top 10 stuff for, how many decades. But this universal cross-site scripting is a little less talked about, right? We have seen a few things over the last year, but that's probably worth 5-10 minutes of your time to go and sort of check that out and get a better understanding for what exactly that means and what it is. And a chance here for a segue if we want to. If we want to go from talking about XSS to an article about Python, not a number. I'm not sure if you're going that direction.
That's the perfect direction to go. Take us through there, NaN.
Excellent. And the reason I'm going this way, this is a name we haven't heard of for a while. Good to see him back in the spotlight. Robert Hansen,
yes.
Also known as R-Snake, who was him and his buddy, my buddy, who I can't remember his online handle. But anyways, they ran hackers.org. And they had they were pretty much the people that anyone would go to if you're doing a cross-site scripting for a while. If the media wanted some, the latest nits and bits, and they were running a website where people were going and actually exploring and doing lots of research and study about cross-site scripting. So he sold off a few companies. He is now back in the news with this short article, but an interesting video, which I haven't watched the whole thing yet, but basically talking about the idea of doing in Python, certain versions of Python, you can have not a number end up giving you an injection. So in the text part here in front of me, I can't watch a video and talk at the same time, but I can look at the text. He talks through a few basic examples where, either, unfortunately for folks who don't know, I expect most of our listeners know, but the way computers count, they're counting on these bit things in your CPU, right? No matter how many you give them, there's still only so many. So at some point, when you add one to a number, it's going to click over and go back to zero, go to a negative number, or go to different places. With modern languages and CPUs, you want to be able to have some sort of concept of something like infinity, or imaginary numbers, or some of these type of things. So then you have to write more code to actually be able to represent those things within your CPU. In Python, this is frequently done with something called NumPy, is a quite popular library, which is used by the machine learning crowd for doing all sorts of math over on that side of the house. But what he figured out is there's a way in here. One example he gives is if you take 1 to the 308, 1e308, so 1 times 10 to the 308, plus 1 times 10 to the 308. This is a way to actually sort of initiate this overflow for the injection. And at that point, the video sort of picks up from there and goes through a few examples of it. I thought it was pretty neat. Like I said, I'm always happy to see Robert around. But I don't know, Mike, if you had further thoughts on that one.
Yeah, I thought it was really cool, and it kind of stood out to me as taking advantage of some call it some creaky aspects, or maybe some surprising aspects of the language that if you work on a language day to day may not be surprising, but type coercion you can do some funny things often with it, and it might be just as simple as it helps with a WAF bypass, as we saw. I'll give a throwback to JNDI, and they were showing how to do variable substitution to compose, JNDI within our friendly, I'm not going to name it, but our Java-based exploit of 2021. Last year's one point, I think we covered something about a scientific notation bug that was also used as a WAF bypass within MySQL. And there's also some really funny things that you can do within JavaScript type coercion. I think there's a famous, and now my mind is just blanked about what if that WAT, if that makes any sense to you listeners who come across the video about JavaScript and surprises, or languages and surprises, in terms of how they do type coercion, and strings become numbers, numbers become strings, NaN becomes greedy and pulls in different types of types for that matter, and surprising things happen in your vulnerability. So I didn't have a really good exploit to show off for this one, but it was definitely, I think, as you said, John, it was neat to see Robert Hansen's name in an article again, and also just a good reminder that languages themselves have surprising things that can be useful for security research. And so we're getting to the end here. There's one more article that maybe will shift away from talking about vulns and talking about how do we keep track of all of the vulns or all of the software that might have vulns in it. And I think this was just a quick update on the OpenSSF scorecards that you highlighted there, John.
Yeah, it's I think we've talked a little bit about OpenSSF over the last few years. How would I say? Linux Foundation backed, has a lot of money coming into it from Google, but they're working on how can we make some of these open source things more secure. In this particular instance, they have worked with GitHub to release version 4 of their security scorecards, which they'll put out things like, it'll give you a number, but also say like, hey, you're using a dependency which is out of date, and things like that. But what the neat part about this is, frequently with these type of things, with a lot of these tools, we're all going 10 million miles an hour, and we're trying to figure out all these different types of things at first. I'm talking we with my developer hat on. If I have to stop and figure out how to integrate a tool into my CI workflow, it might only take an hour, but still it's taken my focus away from everything else I'm doing. So what they've done in this particular case is they have created a GitHub CI Action, which means basically through the GitHub web interface, you're able to go out to their collection of actions, track this guy down, say, hey, add it to my project, and you've got this bad boy is now in there and part of it. You can still control how that runs and when you execute that as part of your I can't remember the name of it, but basically the text file underneath your .github directory for specifying what those actions are and how they run. But still having that there, you can just drop in like that makes being able to use these a lot easier. And with a lot of these type of things we've seen, if you're able to get that tool in there and use it, as Larry was saying in the last half hour, in a format which people are used to within that pull request, that becomes a good thing for everybody. So that's what they're up to, and an update for folks who have tried it in the past and maybe thought maybe it could be made a little bit easier, and now they have.
And now they have. And I think the only thing I add to that is that the results that come back from this are very helpful in the sense of do X to increase your score, or do X to address the complaint that it's making. And those do X actions are very clear, for the most part, are very clear and straightforward. Some of them might be pretty general about having ownership, or is this repo even maintained anymore? That's a little bit harder, especially within organizations, is try to figure out who's responsible for this code. But others are showing out, do you have code analysis enabled? Do you have, what is your merge story? What are your GitHub branch protections? Things like that are very good about just raising the basic practices of your SDLC. So very, very great to see. And I think that there's one last article that I had pulled in that was, unfortunately, didn't have much meat to it. Was in the gaming space about Dark Souls. It had an RCE in it that I just thought was kind of funny, because that creates a situation for some pretty gnarly PvP action in terms of human versus computer versus human. And since I didn't have too much technical details to share about that particular vulnerability, I just turned it into a segue into talking about known vulnerable applications. So I linked in a OWASP project that's talking about common CTFs, common known vulnerable applications. And John, you had just mentioned, we had done here at Security Weekly a lab, or how to build a lab for doing testing. We did that last week or 2 weeks ago. My brain is already gone. So I'm not sure if there's a lab that you would actually love to see yourself, as well as I want to say, listeners, if you would love to see John put together a lab, let us know, let him know, of course. Or John, if you've got a particularly vulnerable sort of human versus machine PvP that you'd like to, as like a CTF or something to highlight here, not sure what's on your mind.
Yeah, I think that could be good. If it's, I'll wait till we get requests on that one from the listeners. But if folks have some sort of lab they want us to throw together, we're happy to do more of those sessions. I think I love doing the hands-on stuff, so I think that's super cool. This was the article actually as foreshadowing with when I talked earlier about, rootless. And the RCE here isn't an administrative one, but still nonetheless, if we can remove a lot of those sort of surfaces underneath, maybe the RCE isn't that big of a deal. So that's sort of what I was thinking through when I was looking at this article. And like you said, there's not a ton of stuff there. And I guess the only other thought I have coming back to me, sort of bitching about the crypto coins, games have been a target of security for pretty much since they've been around. I mean, that's probably, if I had to think through, right? If, either on the Kami, or for me, it was more on the IBM where I was doing like hex editing, getting around copyright protection and stuff like that. So if any industry has their stuff together when it comes to security and like especially if something's running on a customer's premise, a gamer's premise, I'd expect the game companies to do it. So long story short, this stuff isn't, I do recognize this stuff is not easy to secure and do right. And there's always room for error. So I'm not trying to say that I think the crypto kids are completely idiots, but we can all do a little better. How about that?
We can all do a little better. I think that's a great motto for the entire year, perhaps, John. So I think that's a good way to wrap it up. So I'll say thank you for giving us that motto. We can always do a little bit better. Thank you, everyone, for listening. Remember to subscribe to the show. Check out the show notes. And speaking of bringing style to 2022, check out the synthwave artist Zarina. That's Czarina. And with that, we'll see you next week on Application Security Weekly.